In this video, we want to look at combining functions. And there's many different ways we can combine functions. And first, we want to start off with just the basic, the adding, subtracting, multiplying, and dividing. And these are exactly as they seem. And the reason we kind of look at these is we want to kind of understand what these basic ones are. So as we look at other ones, we can say that they're not adding or subtracting, multiplying, dividing. So if we have the sum of two functions, you just add them. Difference, you subtract them. Product, you multiply them. Quotient, you divide them as long as one of them is not 0. So let's start off by looking at them in terms of a graph. Now, we have done this previously in this chapter, but just to refresh our memory, if I said, what is f of 1? Now, in this graph, f is the red function. So when x is 1, f is 0. F of 2, when I go to 2, is 0. G of 1 is the yellow function, and G of 1 is 1. So that's what we've looked at previously. Now, let's say I want to find what is G of 1 plus F of 1. Well, F of 1 is 0, G of 1 is 1, so that's 1. What about negative 3? G of negative 3 is 1, plus F of negative 3 is 2, so that is 3. And I want to kind of show those as we go through here, because as we graph now f plus g of x, we kind of want to do it that way. We go to negative 3 and we say 1 plus 2 is 3. And we put a dot. 1 plus 0 is 1. We put a dot. 1 plus 0 is 1. And we put a dot. 2 plus negative 1 is 1. 1 plus 0 is 1. 1 plus 0 is 1. 1 plus 0 is 1. And so then if I graphed f plus g of x, I would just get that graph, graphing the points. This is similar to when we did our transformations. If I said, what is f of x plus 2? It just added 2 to every value, moved it up 2. Now, we're not just adding one number, we're looking at another function, so it has different values as we go. Now, if we don't have a graph, we actually have our equations or our formulas of our rules, x squared, 4x plus 1. If I want to add these, that's exactly what I do. I just add them. If I want to subtract them, I just subtract them. It's that easy. These are the basic ones. If I multiply, I just multiply. No different than you'd expect. And if I divide, I just got to be careful I don't get 0 in the denominator, but I divide. So those are the basic add, subtract, multiply, divide. It's just as you would expect. The difference, the new one that we got to talk about, is the composition. And it's this new symbol, f of g, this little circle. And what this symbol means is you put the one function inside of the other. It's always the first function inside of the second function. And so the best way to remember this is this f of g of x right there. So if I have two functions, f of x is 3x minus 4, and g of x is 2x plus 1. If I have f of g of 2, this is f of g of 2. Now let's evaluate g of 2. You put 2 into here. 2 plus 1 is 5. And then I find f of 5, and I put 5 into here, and I have 3 minus 4, and I get 11. G of f of negative 3. Now notice the f is first this time. So f of negative 3, put negative 3 into here, would give me negative 9, which is negative 13. Put negative 13 into here, that's negative 26 plus 1 is negative 25. So to know the order, it's the first one into the second one. G of 1, which would be 3. F of 3 would be 3 times 3 is 5, minus 9 minus 4 is 5. So the first function, you evaluate the first, and you put it into the second. That's the composition of functions. Now, we could also do this with f of x and g of x. So there's no number. We just want to take f and we want to put g, 2x plus 1, inside of f. So this is 3 times 2x plus 1 minus 4. If I simplify, this is 6x plus 3 minus 4, 6x minus 4. Now, if you look at the formula and you go back here for a second, consider this problem right here, g of 2. If I wanted to put f of g of 2, this would just be 6 times 2 minus 1, which is 11, which is the same thing we got back here. We now just have a formula for our f of g of x. So if there's an x here, you're going to have a formula with an x. If there's a number here, you're going to have a number. And let's try this one. F of g of x. So g of f of x. So I put the square root of x minus 1 squared plus 2 in. Well, the square root squared becomes just x minus 1 plus 2. So I get x plus 1. Now, the question is, what's the domain? Here we have to be careful when we try to find our domain. Because if you look at the original, or excuse me, look at the final, it's x plus 1. All looks good. But if I go up here, I can't put in a number less than 1. So when you find the domain of these functions, you have to do it before you simplify, because you can cancel things out. So you have to look up here and say, well, my domain, x has to be greater than 1. Don't simplify when you try to find the domain. Now, even a bigger way of using this, because you've seen the composition in Algebra 2, and how we're going to use this as we go on, and we go on to calculus, is really even the reverse. It becomes even more important. So if I tell you that y is the composition of two functions, f and g, where g goes inside of f, the question is, what are my two functions? Kind of breaking this apart, kind of doing the reverse. And there's lots of different answers here, but we're going to go with kind of the basic straight out ones. What is the inside part? That would be x plus 2. And then what would the outside function be? That would be x cubed. For b, for my f and g, my inside part would be x squared minus 3. And my outside part would be just the square root of x. Thinking kind of our parent functions ideas here. Now, are there other choices? Sure. If you consider the top one, just to show you what I mean, we could say that my original function was x plus 1 cubed, and then my g was x plus 1. So when I substitute x plus 1 in, I get x plus 1 plus 1, which gives me x plus 2. But in some ways, you're just making that more complicated than it needs to be. This is kind of the straightforward one, but there's really is more than one answer on many of these. All right, you are now ready for the homework. This is section 2.5, combining functions.